Reflection. Reflection is simply the bouncing of light rays off of a surface, and you probably already knew that because reflection is part of your everyday experience. Not all surfaces reflect light, some do and some don't. Some surfaces absorb most or all of the light that strikes them, and some reflect all or part of that light, and the way in which a surface reflects light determines how it looks to us. For example, the color, for one thing. If you have a red ball sitting here, the reason you perceive that as red is because the light shining on it, say the sunlight is shining on it, this sunlight that we call white light really consists of light of all different colors. When that light lands on the ball, all of the light is absorbed except for the red light. The light that is the particular wavelength or particular frequency that corresponds to red is reflected off, and that enters your eye when you look at it. The red light comes into your eye and you perceive the ball as red. All the other colors are being absorbed. And the same is true for any other color. If you see something that's blue, the reason it appears blue is because it's reflecting blue light into your eye. Now, if you're watching this video, you're actually looking at a computer screen, not a ball right there. And the reason this circle on your screen appears red is because it is emitting red light. That's not really reflection. So just pretend like this is an actual ball in the real world and light is striking it. The reason a red ball appears red is because it reflects red light. Now, whenever you have light coming in and striking something, the incoming light rays are called incident rays. So incident is just a synonym for incoming. So there's incident light rays, and I'll draw these coming in basically parallel. The sun is very, very distant, and in this context you can think of it as a point source, and the incoming rays are basically parallel. But when they strike the surface may appear smooth, but most surfaces are really rough on a microscopic scale. In other words, if you were to zoom in and magnify that surface, it wouldn't just be straight. It would consist of a lot of little jagged sections, maybe some flat pieces, but it's not at all smooth. And so the incoming light rays, the different rays striking different parts of the surface, are hitting different facets here at different angles. So some of these light rays are going to get reflected in some directions, some are going to get reflected in others. And the result here is what we call diffuse reflection. The light scatters. If the surface really is smooth, though, on a microscopic scale, like a polished piece of silver or smooth glass, then the incoming rays, which are all basically parallel, get reflected in a parallel fashion. And if you're watching this, if your eye is over here, this is your eye from the side. Okay, so that's your eyeball right there. And these would be eyelashes on top and on the bottom. So if you're looking and you're looking this way, you see the light enter your eye. You see a bright spot right down here where the light is striking it. This is called specular reflection. And we've seen a lot of this in everyday life as well. Here's a graphic that shows 5 steel balls in this room with some colored walls, and the ball on the right is highly polished and very smooth. You could see this, if this were real, you could see the one on the left for the same reason you could see anything, because light striking it reflects off and enters your eye. But notice there's no bright spots on this one. There aren't any specular highlights, as we would call them, like you see over on these on the right. The ones on the right are literally more smooth on a microscopic scale. This one on the left is more rough, and when the light hits it, it scatters. This one has a more mirror-like finish. And you see other things reflected. You see the red and blue and green walls and ceiling reflected in there because of the specular reflection, as well as the bright spot from the light shining on it, what we would call a specular highlight. And sunlight reflecting off of the water is another example of specular reflection that we're all familiar with.